Hi class, this is number 3 on 7.3. Suppose it is reported that 76% of people subscribe to a cable or satellite television service. You decide to test this claim by randomly sampling 133 people and asking them if they subscribe to cable or satellite television. Is the distribution of the sample proportion normal? So in order to verify that, we have to verify that n times p times 1 minus p is greater than or equal to 10. So the n in this situation is the number sampled. So that's 33. That's one. Let's draw on here. That is, n is always your number in the sample. So that's 133. As I said, sampling 133 people, right? So that's the number sampled. So 133. So let me, 133 is the n. And then the p is this proportion written as a decimal. So it's point, you always move the decimal twice to the left. So, and when you turn it going from a percent to a decimal, so it's 0.76. So it's the p, I'm plugging in for p is 0.76, and then 1 minus p is 1 minus 0.76. Sometimes it's easier just to calculate that, separately, 1 minus 7.76, and then just put the number here. So there's not a lot of calculation, but we're going to have 3 numbers multiplying 133, 0.67, and then whatever 1 minus 0.76 is, then did I say 0.76? And we're gonna see if this is a true statement. Is 133 times 0.76 times 1 minus 0.76, is that greater than or equal to 10? So we're gonna find that out. So I can just use class calc to calculate this for me. So it was 133 times, and I just do shift 8 times by 0.76 times by, and I'm going to put it in parentheses, 1 minus 0.76 in parentheses, and then I press enter. So that is, I don't even have to press enter. It just gives me, it's equal to 24. And so let's go back and plug that in. So this, I multiplied all that out. It is 24. So 24 is, or approximately 24, is greater than or equal to 10. That is a true statement. So it is normally distributed. That's good. That's good news. So we're going to say yes, the distribution of the sample proportion is normally, since this is the case, that is true, that when we plugged in the n times p times 1 minus p, it was greater than 10. So this is our answer to part A here. And then what is the mean of the distribution of the sample proportion? Well, these are just formulas that you have to have remembered. Now they're different. Now we have to think differently, right? We were talking about the mean in problems 1 and 2 in this 7.3 homework. Now we're focusing on the proportion, right? 76% of people are saying proportion of the amount of people. So that we have to use different formulas. So that for the mean of the p hats. Now we're not talking about the mean of the x bars anymore, right? So the mean of the p hats is just equal to the sample, is not equal, but the population proportion, which in this case is the 0.76, written as a decimal 0.76. Okay, then the standard deviation of the p hats, and that's the next question they ask us. Well, that's equal to the p times 1 minus p all over n, which is very similar to this. It's kind of like real similar. And we just have to plug in what that is, and then we'll find that too. But this first answer is just 0.76, the mean of the sample proportion. And then the second part, let's go find that on using our, this is kind of can be a complicated thing to input. So let's see how I do it. Like so it's the square root. So I'm going to put in SQRT. I'm going to put in parentheses the 0.76, or that's the times by 1 minus 0.76. All, and I'm going to do one more parenthesis there. So I put all the numerator in parentheses so the calculator knows it's all in parentheses. And then I put divide by. So now it's still knowing that I'm under the square root still. Divide by the n, which I believe, let's go back really fast. N was 133. Like right there is the n. So I plugged in 0.7, 1 minus 0.7, and over 133, and I'm calculating, I'm having the calculator do this for me. 133, so do you see that this is the p times the 1 minus p all over n, and that's my answer, 0.037, 0.037, 0.037. So that's exactly what they want, 0.037. That's what they want for that one. Okay. And the 0.76 was what they wanted above, and the yes is what they wanted there. And then now we move on to the next part. Suppose we find from our sample that 74 subscribe to cable or television service. What is the sample proportion? So 74 of how many? So 74 answered, yes, I have cable TV or whatever, or satellite TV. 70, so what is the sample proportion? They're just asking what percentage is that? So if 74 of the sample that were asked have cable TV, what percentage is that? Well, you can, the easiest way to do that is just to do the number that have the subscription or the cable or satellite over the total number sampled. So that's, that would be the 74 that answered yes, we have cable, over the total 133 that were sampled. And this will give us a decimal number for the proportion. So let's just find that. So it's, what is that? It's we said 74, was it 74? 74 over 133. And I don't need a big, huge calculator to do this, but 74 divided by 133, and that's 0.556, 0.556. Well, I don't know how many decimals they want here. And they don't say, but 0.5, it looks like they would accept any number of decimal places that you put. 0.556, so I wonder if they would just like accept 0.556. Let's just see how they accept that answer. I don't believe they're telling me. Yeah, okay, so it looks like you just put in 3 decimal places and they're happy with that. Okay, what is the probability that at least 74 subscribe to cable or satellite? Now, be very careful with this problem because 74 seems like it's our lower bound, that at least 74. It sounds like it's our lower bound, but it's not our lower bound. This proportion that we just stated, that's our lower bound because this is a sampling distribution of a sample proportion. It's not the number of people in. Hope that this makes, these are proportions, sample proportions on the bottom here. These numbers along this x-axis are decimal numbers. And they're not, there's no such thing as like 74, and 74 is not a number along this x-axis. So we have to convert that 74 into the sample proportion that they asked us, or we already calculated above, And we need to use that number and not the 74 here. So that's huge. That's the number one mistake that students make with this problem. So let's look back. What was the sample proportion? It's 0.556. So I'm going to use that. That's the number along the x-axis here, 0.5666. So 0.76 is here. But 0.556, I believe it was. That was the sample proportion from here. So 74 subscribers would be a proportion, would have a proportion of 0.556 that have cable or satellite. So we need to find what is the probability that at least, when they say at least 74, they're saying at least 55% have cable or satellite service. So if they have at least 55%, that means like 55% or larger, right? So this is the area under the curve that we want to find. So our lower, if we were doing our TI-84 calculator, our lower bound would be where it begins. I'm reading it left to right. Where does this shading kind of start? And it's starting at 0.556. And then where does the shading stop? It goes on to positive infinity. So like here would be my bound here is like, you know, the 0.556, and then positive infinity would be my other bound over here. I can't put in positive infinity, so I put 1e99. And then my mean, I put in my mean, which is 0.76 of the proportion. This is a distribution of sample proportions. So the mean is 0.76. And then the standard deviation, that's the number that we calculated up there. Now we probably want, I would probably just 0.037, probably go with 0.037, probably be accurate enough for us. 0.037. And let's go ahead and, so that would be your input on your TI-84 calculator to do this problem. But let's see what it looks like on ClassCalc. So I'm going to do stats, distant plot, normal distribution, my mean, the 0.76, and standard deviation, 0.037. Was that the answer? Yeah, 0.037. And I'm not, at least that's accurate to 4 decimal places. That's probably going to be accurate enough for us. Okay, and then now we just said this is our lower bound that we want to input on our left there. See, the X is in the middle, so we're going to put the lower bound on the left, the upper bound on the right. So the upper bound was 0.556. The lower bound, 0.556. And we might even want to be more accurate to that with that. Oh, and then they said like, okay, well, then the upper bound is 189, which is positive infinity, which we already have input. So they're saying the probability is 0.999999999, which basically like is one fold. We're almost, I mean, 0.999 or 99.99999% sure. So let's double check our answer here. Yeah, and they just rounded to 4 decimal places. They just said 1. But I'm wondering if they would accept an answer of just 0.9999. If I maybe just like had it to, because they should. Yeah, they would have accepted 0.9999 as well. So let's see, hopefully they would have done that to 3 decimal places as well. They would have been accepting it. Okay. Yeah, so this is a pretty good problem that like some problems have a very small window of the acceptable answers that they actually are not quite wide enough. And if you don't if you don't, if you round off your information too early, then it can be bad. But anyways, and it could throw off your final answer enough that would be outside of that window, but they've made this window pretty large, so that's good. All right, well, if you really are confident, I have a problem correct, and I think that they just marked me wrong, just like email me. It's unfortunate, but sometimes once in a while that will happen, unfortunately. All right, have a great day, everyone. Bye.